Okay, so second part of this key area, well actually quite a chunk of this key area, is really to do just with definitions. Passive transport, diffusion and osmosis. So I just want to take you through these. This is a quick video one. So passive transport, you're going to see this a lot and you'll be quite often asked, is it passive? Or to ask, why is it passive? Okay, so it is the simplest way of moving stuff. And what we mean by passive is there is absolutely nothing that you're working to do. It's all just to do with a difference in concentration. So you need to have a high and a low. And then passive transport, it just basically rolls down a hill. So think literally freewheeling down on a bike. You know, so if you have, this would be the high concentration, this would be the low concentration. So anything that's up in the high just rolls down to the low, and that'll keep going, and this will get lower and lower and lower until effectively you end up with it just being flat as everything falls kind of across the way. But passive transport, no energy, high concentration to low concentration. Okay, so one of the definitions that you need to know is diffusion. You did this second year, you will have seen the word diffusion, but that's been a while. So diffusion is the movement of molecules from an area of high concentration to an area of low concentration, and you can either use the word down or along, I normally say down, a concentration gradient. You literally need to just memorize that, and if that means chanting it 50,000 times, that's fine. You know, put a little voice note on your phone and listen to it every morning. Whatever works to get this in your head. It is the movement of molecules from an area of high concentration to an area of low concentration down a concentration gradient. So the only thing that matters for diffusion to work is, can you dissolve it? So if something is insoluble, if it's too big to dissolve, then you can't get a concentration gradient. It's just not a concentration, because concentration is basically mass in a volume. So watch out for that. If you have that, it works grand. So gases, liquids, diffusion is good for. Like if you spray some perfume in one corner of the room, you will have a high concentration of the perfume there, and then it will slowly move through the high concentration to the low concentration. So if you're on the other side of the room, you'll eventually smell it. Okay. Right, one particular case of diffusion that you need to know and memorize again is the definition for osmosis. So osmosis is diffusion, but it's a very special case of diffusion because it is the movement of water. So instead of saying movement of molecules, it is the movement of water, and it's only water. From an area of high concentration to an area of low concentration, so that's the same, through a selectively permeable membrane. The only selectively permeable membrane that we've told you about, and the one that we're going to use all the time, is the cell membrane. So basically osmosis is the movement of water through the membrane, but you need to know the full definition. Movement of water from an area of high concentration to an area of low concentration through a selectively permeable membrane. Again, it's a chanty one. The high and low concentration is water concentration. You're going to have to be careful of that later on. So what that means is, if we look at the one at the bottom here, it's saying low sugar, but that means high water, because there's more space for the water because you've not got much sugar in it. And the other side, we've got high sugar and low water, and then they've got a membrane in between. So the water will go from the high to the low, so the water will move that way. Okay, if the sugar could get through this membrane, the sugar would also move this way, but that's different, and that's diffusion, just of sugar.